When sustainable principles are embedded at design intent stage, BIM allows engineers to evaluate energy performance, material efficiency, carbon footprint, and life cycle cost. Well before construction begins, this proactive approach leads to informed decision and making and optimized designs. As projects move from design to site execution, BIM ensures better coordination among stakeholders, minimizes design conflicts, reduces rework, and control material wastage. In large public infrastructure projects such as highways, metro rails, bridges, water supply networks, public buildings, these benefits translate into savings, timely delivery, improved quality, and reduced environmental impact. For academicians and professionals alike, understanding BIM enabled sustainability is essential. It equips us to prepare industry ready graduates, support government initiatives, and contribute meaningfully to smart, resilient infrastructure development. This FDP is therefore a timely initiative aimed at bridging the gap between theory, digital tools, and real world execution. I'm confident that the sessions planned in this program will provide valuable insights into sustainable design strategies, BIM workflows, and practical case studies from public infrastructure projects. I encourage all the participants to actively engage with the resource person and make the most use of that learning opportunity. I once again welcome you all, and now I request Raghunath Reddy to introduce Kranti Garu.
Thank you, madam. It is our pleasure to welcome J. Kranti Kumar Reddy, currently working as Executive Engineer in the Department of Central Public Works Department, specialized in the execution of large-scale government infrastructure projects. And he pursued his BTech from Sri Venkateswara University, and then he joined MTech in Transportation Engineering in IIT Madras, Chennai, and he secured All India rank 33 in GATE 2026 and All India rank 259 in GATE 2013. And also he secured All India rank 40 in ESC 2016. And then he joined as an assistant executive engineer in CPWD, and he executed 400 crore NIT Andhra Pradesh campus over 172 acres in phase 1A and phase 1B, and delivered academic and residential and utility buildings adhering to green building norms. And then he promoted to executive engineer in 2022, and he led development of 704 crore NACIN campus spread over 500 acres, focused on master planning, phase execution, sustainable infrastructure, and project delivery tracking. And then currently he is working as an executive engineer, CPWD Bangalore, and he is responsible for planning, coordination, and execution of EPC works as per approved drawings, including tendering, building, quality control, and statutory clearance. He has experience of 9 years in Central Public Works Department and specialized in execution of large-scale government infrastructure projects. And also he is skilled in developing coordinated and data-rich 3D BIM models using industry standard tools with a strong grasp of interdisciplinary integration, spatial planning, and construction sequencing. Proven ability to streamline workflows, enhance design accuracy, and support efficient project delivery through collaborative coordination with consultant and stakeholders. He committed to leveraging BIM to drive quality, reduce rework, and enable informed decision making throughout the project life cycle. And now please let me warmly welcoming Engineer Kranti Kumar Reddy to deliver lecture.
Thank you, Raghu, for your brief introduction about myself. Good morning everyone. I hope I am audible to everyone, right?
Yes, sir.
And my screen is visible, right?
Yes.
Yeah. So today I will be speaking on sustainability through BIM in public infrastructure projects So in public works, right, sustainability is no longer an optional feature or it's an add-on. It's a responsibility. Through this presentation, I will try to explain how BIM helps us translate sustainability from drawings and design intent to the site execution, actual site execution, not just on paper, but in real construction. I will also touch upon BIM, how BIM supports resilient, energy efficient, and low carbon building assets, especially in long-term projects like hospitals, offices, and infrastructure buildings. So let me brief explain about myself. I think so already Raghu has explained me about myself. I'm a Kranti Kumar Reddy, presently working as an executive engineer in CPWD. I have been involved in execution and management of large infrastructure projects like hospitals, office buildings, and institutional campuses like NIT Andhra Pradesh and Nasin campus. Mostly I worked in EPC mode. So today's discussion is not theoretical. I will share insights from actual project experience, particularly how sustainability can practically implemented using BIM tools. First, let us understand why sustainability is not negotiable in public projects. One, we are dealing with public money, so we are accountable not just for construction cost, but entire life cycle cost, including operation and maintenance. Second, the public buildings typically last for 50 to 75 years and sometimes even more. So the decision we take today will impact energy bills, water consumption, and maintenance costs for decades. And third one, energy, water, and maintenance expenses are ultimately borne by the government. Poor design means recurring financial expenditure on government. So, and finally, India has made national and global climate commitment. So public infrastructure must lead by example in reducing carbon footprint and resource consumption. So that is where the BIM becomes a very powerful tool. It helps us to take informed decisions early when changes are still easy and cost effective. So sustainability in public infrastructure, when we talk about sustainability in public infrastructure, we are not only talking about green buildings. Public infrastructure includes like hospitals, offices, institutional campuses, water and energy assets, transport systems. So these assets serve to millions of citizens. So sustainability here means doing more with less energy, less water, less waste, while still delivering safe, durable, and comfortable buildings. Since these assets are funded by public money, sustainability becomes moral and financial responsibility. So many people think sustainability only means Griha or lead rating, but sustainability is much more practical than that. It means lower energy bills, which reduces government expenditure. It means lower water demand, which is critical in Indian cities. It also means low maintenance, longer building life, and better indoor health, especially important in office and hospital buildings. So in short, I would like to say sustainability is a life cycle performance. It's not an initial construction. So sustainability in public projects rests on basically on four pillars. First is environment, efficient use of energy, water, and material. Second one is economic. We focus on life cycle cost, not just on initial construction cost. And third one, social. So which deals mainly with user comfort, safety, and inclusivity. And fourth and final one is governance. So which deals with transparency, auditability, and accountability by the government officers. So I would like to say BIM helps us in address all these four pillars together, not in isolation. So traditionally, sustainability is discussed after drawings are finalized, and value engineering happens too late when changes becomes expensive. So during construction, changes can lead to waste, rework, and delays. Most importantly, operation and maintenance team are not consulted during the design phase. So the key issue is sustainability. The key issue is not lack of intent, but lack of integration. So BIM resolves this integration problem. So coming to the BIM fundamentals, before I'm discussing further, I would like to discuss regarding what is BIM. Most of the people, I don't know whether you are aware of the BIM or not. So before going further, let us clearly understand what BIM is. And I would like to say BIM is not just a 3D model, it's a digital representation of a building with data. One model can be used for planning, coordination, analysis, construction, and facility management. So that's why we can say one model and multiple uses. So BIM combines geometry plus information. So which I already said, one model we have multiple uses where you use all this. So before coming to that, I want to say whatever we model in BIM, like we model everything, like every wall, every structure, slab, conduits, pipes, equipments, and which having all the data, sizes, material, performance, all these things will be modeled in the BIM, and on this BIM model, every one will work. So this BIM enables collaboration instead of working in isolation. So before going, I would like to say this BIM grows in dimension. Like 3D means geometry, where we can physically model, like whatever we are going to construct, we will model the complete building or complete campus in BIM. So I would like to say the BIM means it's not a software, it's not a tool. It's a process. So, and once we model, especially BIM means BIM consists of various softwares, like we use mainly Rivet software, Navisworks software, Tekla software. So all these different process together calls as a BIM. Okay. So first, once we model complete construction, what we are going to construct. So this is called the basically 3D geometry. Later, we add time and construction sequence to this geometry. So 3D plus time and construction sequence will gives you the 4D dimension. And if we add to the 4D dimension, if we add quantities and costs, it becomes the construction. And if we add, while to this model, if we add the sustainability and performance, which I will discuss what is the sustainability and performance model. So that leads to the 6D. And if you once it is completed, if the model supports the operation and maintenance, then such model can be called as a 7D dimension. So sustainability is therefore built in BIM and it is not added later. So BIM workflows in level of development. So we cannot when we are developing BIM, we have to develop from start. Like initially LOD 100 and 200, which means concept and massing validation. So later comes, so we add one more data to these models. So it becomes LOD 300, which is used for tendering and coordination model. So during construction, we develop 350 to 400 model where we exactly gets shop drawings and fabrication drawings and good for construction drawings. So which we will use for the actual construction. And finally, LOD 500, once the complete construction is done, though as-built modeling will be incorporated in the BIM model as an asset data for facility management and handing over. So this ensures clarity at every project stage. So traditional CAD is a line-based and reactive, whereas a BIM is an object-based and predictive. In CAD, all disciplines work differently on their own softwares. Like architectural will work separately, structural will work separately, MEP team will work separately. But whereas in BIM, all disciplines will work on one model and everything is integrated. So this shift from drawings to data is critical for sustainability. So especially in EPC projects, contractor usually prepares BIMs. The role of CPWD, we used to review, validate and enforce standard on it. And BIM is not a decoration or presentation purpose. It's a decision supportive tool. It helps us to understand and take the informed technical and financial decisions during planning stage itself. So coming to the design stage, what sustainability features we can incorporate in the design stage. So the maximum opportunity for sustainability lies in design stage. The BIM allows us to test multiple options digitally before construction begins. So the multiple options, like suppose when we model a building, we will model all the materials which we are trying to use. So once we model it, initially we suppose if I take an example, if we model a building with red bricks, so we can do what type of energy savings can be happen, or if we the elevations, when we are giving the structural glazing, what type of heat loads will be coming to the building, and if we provide the red bricks, what kind of energy savings can be made to the building can be evaluated. And if we found if it is high, if we want to reduce, then we can immediately switch, we can immediately modify the material property like red bricks to the AACC bricks. And if you give the properties of the AACC block, so our fly ash blocks, or glazing properties of the glass which we are using, or we can change to the single glass to the double glass, so that we can immediately see the changes what can be that building, constructed building can be leads to. So this means a better decision can be taken with a minimal cost implication. So any changes made during design cost will be very little and expensive, but the same changes during construction or operation becomes extremely expensive. So BIM allows us to take a right decision early. That is the biggest advantage. So BIM also helps us study building orientation. Hello?
Please mute yourself. The disturbance from some of you. Please mute yourself.
So can I continue?
You proceed. Yes, sir. Yes, you can.
So BIM helps us study building orientation, sun path, heat gain analysis, and daylight optimization. Especially when we construct any large scale buildings, we can orient the buildings in all directions and we can see how to reduce HVAC loads, how to make it energy efficient buildings. So these decisions can be taken before construction using simulation rather than doing trial and error during construction. Also, the BIM helps in optimizing the wall assemblies, roof insulation, glazing ratios, and shading devices. As I said, we can optimize the glazing, how much wall portion should be there, how much glazing should be there, how much roof insulation I have to make, so that energy can be saved. These all comes under the envelope, building envelope. So everything is a digitally tested, no trial and error on site. So a better envelope means lower energy demand for entire building life. So also the BIM is based on energy modeling, helps optimizing the HVAC loads, equipment loads, light simulation. It also checks feasibility of renewable energy integration like solar. So this leads to a realistic and achievable energy targets. Coming to water sustainability. Water sustainability is critical in Indian public projects. BIM helps optimizes fixer flow rates, STP capacities, rainwater harvesting, and dual plumbing layouts. This ensures like minimal fresh water demand, and what is the maximum reuse can be done. BIM also enables simulation driven decisions. So energy performance, which I already said, daylight availability, heat gain, water demand, and even embedded carbon can be analyzed. So sustainability becomes measurable and not a theoretical. So coming to the clash detection and constructability. So clash detection is one of the most practical benefits. So it avoids service clashes where different services like HVAC, firefighting, land services, especially when it comes to the hospital building, there are so many services like nurse call system, gas manifold, like gas manifolds also has to be taken. So when multiple services are there in the building, so how to avoid these clashes during execution can be dealt in design phase itself, and based on this we can rework out it so that there will be no clashes in the drawing stage itself. So every avoided rework is directly a sustainability. So which I said, BIM is not just a 3D, it's a data enriched model, and where this can integrated with multiple architectural, structural, MEP and planning. So it supports performance based design and provides a single source of truth for all consultants and contracts, which ultimately used for better execution. So BIM connects directly the entire project journey from client intent to site execution. So sustainability is defined at the beginning itself through clear targets for energy, water, carbon and life cycle performance. Climate and site conditions are analyzed early so that orientation, massing and layout supports energy efficient or not. A coordinated BIM model brings architectural, structural and MEP together, avoiding isolated decision making. Fourth, energy and carbon emission converts sustainable goals into measurable performance outcomes. Fifth, clash detections and coordination ensures constructability and avoids rework, material waste and delays on site. Fifth, time and cost, if you link to the model to support a realistic planning, accurate quantities and transparent billing. And finally, it supports site execution so that what is designed and is simulated is exactly what gets built. So sustainability flows from design intent to site execution. So coming to the site execution, now once if it is done, now how we will transfer this BIM to the field. So BIM supports execution through model based shop drawings. So once the model is developed, So based on that model, we generate good for construction drawings and which we will issue to the construction team to execute. So the drawings can be accessed on site using QR codes. Once if they click that QR codes or scan, they can see the actual model, how the building will come. So look, like where the walls will come, where the shafts will come, where the different types of services will be coming, so that site engineers will have a clear idea how to execute rather than seeing the 3D, 2D drawings and understanding and coordinating with the all different fields. Instead of that, site engineers can see at one particular point, seeing the model, what else will be coming in the model itself. Like at this location, conduit will be coming, HVAC shafts will be coming, and firefighting lines will be coming. What else lines can be coming, so that he can take a better outlook on execution. Also, quality assurance and quality checks, inspections can be digitally linked to the model. Laser scanning helps validate site execution against the BIM models, and the as-built model is continuously updated, creating a reliable digital model. As and when, suppose if we find anything there, if you are changing anything, then we can immediately update in the model itself. So your as-built model, no need to prepare separately. Once the construction is completed, we no need to complete. I hope everyone is getting right whatever I am saying. If you have any doubts, please feel and you can ask. Am I audible?
Yes, you are audible.
Okay. So usually everyone thinks like, I can say that clash detection means a sustainability. So the slide highlights a very important idea. The clash detection is not just a technical exercise, it's a sustainability in action. By detecting clashes early, we can, as I said, we can avoid rework, material waste, and avoid delays. Each avoided clash means it saves a cement, steel, manpower, and especially time. So this is what the key message here is. Every avoided rework is a sustainability. So coming to this construction sequencing, the 4D BIM links construction activities with the time. So we can visually see what we built, when, and in what sequence. So this helps in logical sequencing, reduce ideal machinery, and optimize manpower deployment. In large public projects, this directly improves productivity and site discipline. So I would, you can see this is a visually how the construction sequencing in BIM can happen. You can see how the BIM is integrating with the project schedule. Activities are visually linked to the BIM model. This helps planners and site teams understand dependencies and critical paths clearly. So this is far more effective than reading bar charts alone. And next, coming to the 5D modeling, where 5D BIM model focuses on quantities and costs. Quantities are extracted directly from the model, improving the BOQs and accuracies. This reduces excess procurement and controls material wastage. For public projects, this involves transparency and audit confidence. So here you can see, you can visualize this 5D modeling services. How the construction modeling with the cost projection over a period of time, what is the actual cost involved, what is the average cost. So here you can visualize how the building can be progressed and what will be the cost during over a period of time. For each month, what will be the cost that is required and what type of materials has to be procured to finish the executions. All those things can be visualized in the 5D BIM model. So, which I said in public projects, this 4D and 5D BIM has additional benefits. Construction can be phased in live campuses, like all campuses like office buildings, hospital buildings, all those things. Time-linked simulation helps during approvals and reviews, and BOQ automation supports better cost control and transparent reporting for the stakeholders. So quality control integration. So BIM can be linked with quality control processes, inspection stages, checklist, test reports can be digitally mapped. So this shift quality control from reactive to planned and traceable, and it improves a long-term durability of public assets. So coming to the cost, time and sustainability. So in EPC projects, especially cost, time and sustainability are closely connected. BIM helps in balancing all these three without compromising the execution speed. And sustainability is not an additional burden, it is a result of better coordination and planning. So there is a common myth saying that sustainability increases cost. In reality, sustainability reduces life cycle cost. Initial investment may be slightly higher for planning phases where regressive planning has to be done, where different softwares is required for the effective planning. But once the proper planning and proper BIM has been done, then operational savings over 30 to 50 years, over 30 to 50 years, or operational savings will be a huge and it's a significant. So BIM helps us prove with that data. So BIM helps execution team also. It directly supports execution team. It enables transparent building and milestone tracking, where we are standing and how rescheduling can be done with a effective. Disputes reduce. It also reduces disputes because quantities and scopes are clearly defined in the BIM model. And records are audit friendly, which is important in especially in a government projects, which can be easily tracked. So coming to this risk reduction, BIM also helps in reducing project risk. Variation reduces because issues are identified earlier and clashes can be done before. And it forecasting improves over time and cost. Change managements become controlled and documented. So basically the typical outcomes observed in BIM enabled projects based on the practical experience, the BIM enabled projects shows a clear benefits. Construction cost reduces 8 to 12% and 10 to 20% optimization in service spaces. It means that when we are initially planning, we can betterly coordinate the spatial planning of any building, and like services, electrical E&M service rooms, HVAC rooms, and all service rooms, whether it has been planned or not, can be seen at initial design stage itself. And operational cost also will comes down. And improved facility management, uptime improves, and documentation quality also becomes much better when we adopted BIM. So now coming to this operation and maintenance and asset life. So the real value of BIM starts after construction basically. So the public building operates for decades. So the BIM has to support operation, maintenance, and asset life management. This is where the sustainability truly pays back. So BIM provides structured and asset tagging. So we can tag all the assets in the entire model, and the BIM maintenance schedules and equipment warranties are digitally it can be stored in the model. So the BIM has a reliable digital records for decades, and this supports smoother handing over and long-term facility management. These are all the benefits in the post-construction, and sustainability does not end after completion. BIM enables lower energy bills, predictive maintenance, and reduced downtimes. This ensures consistent service delivery in public projects, especially in hospitals where big infrastructure campus developments are happening. So the facility management integration and digital twin, which means the BIM model continues to be used even after the construction during operation and maintenance of the building. All major assets like AHUs, pumps, equipments, medical equipments are digitally tagged within the BIM model. Each asset carries its digitally, such as what is it make, what is the capacity, what is the warranty, and what is the maintenance history happened to that equipment, which we can easily see, and which if we want to shift it, if you want to replace it, which can be easily taken, a decision can be taken. Maintenance shifts from the breakdown base to main, if we are not maintaining, sometimes there may be have breakdown based, we have to stop. Instead of that, we can plan it. Preventive maintenance can be made, which can improve reliability. When BIM is integrated with BMS, building management system, energy dashboards can be viewed directly against the building spaces. Like at each space, what is the HVAC load that is happening? What is the energy load that is happening? And we can monitor in when it is mounted with the building management system, we can exactly see in the dashboards which rooms are vacant and lighting is going on, AC is switched on. So all this can be automatically monitored, and we can try to reduce wherever it is effectively manner, so that our energy can be usage of energy will comes down. This helps in identify the high energy consumption areas and take corrective actions early. Over the life cycle of the building, this results in lower operating costs and better asset performance. Especially when we consider a big hospital buildings, this ensures a better life cycle rate of investment and long-term value from the public investments. So I would like to take some case narratives where we used to execute in this. I will consider an ESIC hospital, which I am considering. Hello. So do you want me to give a break? Otherwise, I have maybe hardly 10 slides, which we can complete also. So can I complete it without any break?
You can complete, sir.
Okay. So especially in a ESIC hospital, which we are executing, which we are trying to use this BIM, and BIM helped in coordinating and multiple MEP services. And HVAC zones can be optimized for energy efficiency, and change orders can be reduced due to the better upfront coordination. And this demonstrates BIM practical values in the EPC execution especially. So these are the different projects which we are executing, which I am executing. So this shows the real EPC hospital project executed in BIM. The image represents the integrated 3D BIM model of hospital, which acts as a single reference for design and execution. This model on right and bottom shows MEP systems, HVAC, electrical, firefighting, and medical gas, and which is developed and integrated in the model itself. And once all these models has been done separately, these all models will be exported to Navisworks software. These all models usually done in Revit software. And once these softwares are individually they are modeled, and they will take to the Navisworks software, where all these models are clubbed together to make a single federated coordinated model, where all these clashes will be detected there. Once the clashes are found, then we will sit across with all the different disciplines, so that we can take we can suppose if any intersection happens with the HVAC and firefighting, so we will see that whether HVAC has to be lowered or firefighting has to be lowered. So once these decisions are taken, so these clashes will be resolved in the BIM model itself, and we will make a finally clash free federated coordinated model, and from which we extract all the good for construction drawings, and we will issue to the site. So instead of separate drawings, architectural drawings, structural drawings, MEP drawings, E&M drawings, instead of issuing separately, all services are planned together in a single coordinated environment. This helps in resolving clashes early between the structure and between the services, especially in hospital where we will have a lot of services. This is a betterly planned, and HVAC zoning were optimized based upon the functional requirements and reducing over design and improving energy efficiency. Because coordination was done in the model stage, any changing to be done, it can be easily done, and during execution, changes can be significantly reduced. Overall, the BIM help improve constructability, control cost and time, and ensures smoother execution of any project which is executing. So coming to some challenges and way forward, while the benefits in BIMs are clear, the implementation in Indian public projects has its own challenges. BIM maturity is uneven across consultants, with some consultants or teams still work largely in 2D environment, whereas this BIM has been largely been implemented in all foreign projects. Without this, they will never start an execution. But still, this has to be taken to Indian projects also. Nowadays, the most public projects still follows traditional system, which are not naturally aligned with integrated BIM flows. So there is an initial requirement for investment in hardware, software, and training, which often becomes a hesitant point. Like we need to invest lot of things in the softwares, like Revit software, Navis software, Tekla softwares, so ArchiCAD softwares. All these softwares we have to invest on that. On this hard, like for running the softwares, we need to have a proper systems also. So proper hardware also should be there. and apart from having this hardware and software, we need to train all the employees. So I would like, even if you see when we are studying BTech, we never know about any of the softwares, but these are the softwares which are really useful during the execution. So whatever we study during, right? So I give a suggestion, at least when they are in the 4th year, we have to so everyone, especially in public projects. So what they say is, so whenever we send an estimate, we send basically based on some preliminary planning. We'll prepare an estimates and we submit to clients. And once the client sanctions, they immediately ask us when the construction work is getting started. So we have to start the construction work within 1 or 2 months. So which is not practically possible. So if you see the 100% of project time completion, we have to invest 40% of the time in the planning stage itself. So we are, but in practically the main challenge is we are hardly spending 5% project time and we start the work. Once we start the work, then during execution, we see that there is lot of clashes with the architectural, structural, all those things. To resolve these issues, we deliberately stop the work, and instead of finishing it in 100% time, projects are delayed by 100%, 200%, 300% time. So instead of that putting 5% planning, if we could able to make 30% out of the entire planning period, you provide minimum 1/3 of the project timelines to the proper planning and using these softwares, then we can ensure that the projects can be executed very smoothly. Because once the proper planning in BIM has been done, everyone will know that there will be no clashes, and every engineer can visually see what are the model he can construct and what are the how much quantity of materials is required. He can contractor can properly plan, and properly material procurement plan also can be happened. So in many cases, the BIM adoption is optional, but we should make it a mandatory, leading to partial or inconsistent implications. So for effective adoption, a clear client-driven mandate is essential, particularly in large public infrastructure projects. So initially, we have to say as a CPWD, as a client, we have to explain to the client, no sir, initial planning has to be done properly. So because of that, projects can be completed in smoothly with a more time effective and less cost. And as a college professors, they have to tell initiative that yes, this is the coming generation, this is the field. So where you have to excel in this field. So the ground realities, as I said, the biggest ground reality is a skill gap, especially at site and junior level engineers. Most of the people, they don't know what is BIM itself. So many teams are still comfortable with traditional drawings and are not fully trained to work with BIM models. There is also a natural resistance to change because BIM seems as an extra work rather than a supporting tool. In several projects, BIM is adopted only partially, used for coordination, but not for planning, billing, and quality assurance. So somewhere only they are implementing partially, because all at a time we cannot implement. So at least they are implementing partially. So we have to take a step to, at least we can do 3D modeling, at least we can do coordination, clash detections, that is fine. Later on, we can switch to 4D modeling, 5D modeling, and sustainability and operation and maintenance. So this partial adoption breaks the continuity in the BIM workflow and limits its real benefits. So we have to explain to the clients, to everyone, what is the benefits of this 4D, 5D, 6D and 7D models. So the contractual provisions in many tenders don't clearly refines the BIM responsibilities, deliverables, and enforcement stages. So as a CPWD, as an executive engineer, when we are preparing the NITs, we should clearly represent what exactly has to be done in the BIM. Until unless we mention properly, contractor will never implement. So because of this, the BIM often remains optional instead of becoming a part of execution culture. Addressing these ground level realities is essential for successful BIM implementation in public projects. So what CPWD can do? I said CPWD has a key role to play. We need to clearly define BIM deliverables defined in tender, and stage-wise enforcement has to be made instead of one-time submission, and capacity building of officers and staff has to be done. And most importantly, focus on use of BIM, not just software. So coming to this conclusion, I would like to conclude. So the BIM bridges the gap between the design intent and execution reality. It enables measurable, sustainable outcomes. BIM is essential for future ready projects like hospitals and other infrastructure projects and campus, all those things. So as I say, it supports the entire life cycle from design to operation. So from concepts planning, detailed design, analysis, documentation, fabrication, so and construction and operation and maintenance, any renovation, all these things is an entire life cycle: design, build, operate, and maintenance. So this is a complete life cycle. So finally, I would like to say BIM is not a software, it's a process, and sustainability is not a feature, and both put together, it is a governance tool for public infrastructure. Thank you. Thank you for giving me this opportunity. Now I would like to stop here, and I think so we will take a break, and any doubts regarding this we can discuss later. Is it okay?
Yes, sir. It is okay. We can join after 10 minutes.
Okay. So thank you.
Members are requested to join by 11:10 again. Something.